All right, we come now to David Hume, the Scottish philosopher. Hume lived, as you can see there, from 1711 to 1776. Descartes lived from 1596 to 1650. So as you can tell, there's a fairly significant gap between the two of them. So when Descartes would have been writing his famous works, that's about 100 years before Hume would be writing his. And in that intervening century, a lot of stuff happened. A lot of stuff happened politically, economically, religiously, but perhaps more important for what we're doing, a whole lot happened scientifically. Descartes is at the beginning of the scientific revolution. He is not quite as old as Galileo, so he's a younger man than Galileo when Galileo is having his confrontation with the church. But he is already at that point an active mathematician, an active physicist, an active participant in the debates over all the same issues that Galileo was talking about. But Hume comes, at least from the perspective of people of his own time, after a lot of the great discoveries have been made. So the 1600s and early 1700s are for many people sort of the high point of the scientific revolution, or what has come to be known as the first scientific revolution. There's quite a few people who will say there was kind of a second scientific revolution in the 1800s, but we won't be getting to that here. There is one figure, though, who dominates the scientific world, especially the scientific world in the British Isles, which is, of course, where Hume was from, more than any other, and that was Isaac Newton. So what's so important about Newton? I mean, scientifically, I hope you know the answer to that question. Newton provided the first really theory in physics, or at least the first post-Aristotelian theory in physics. And while Aristotle is good on a lot of stuff, on physics, Aristotle is really tough. And I don't mean like tough to understand. I mean, it's hard going if you're a fan of Aristotle reading some of the stuff he had to say about physics. The key thing that Aristotle was wrong about was honestly something that you can sort of give him a pass on, I think. Aristotle thought there were two different forces governing the movement of bodies on Earth, one on Earth, or one really from the moon in, or within the orbit of the moon, let's say, and another from the moon out. He thought there was a force that was causing, not even really a force, but he thought there was a natural tendency for objects to fall towards the center of the Earth if they were located inside the orbit of the moon around the Earth. And he thought that outside of that orbit, and including that orbit, so including the moon, there was a natural tendency to move in roughly a circular way. Along with that, right, Aristotle had all sorts of weird things to say about the planets and their orbits and things like that. But that approach to thinking about gravity in particular, which of course, like everyone knew about gravity. You sometimes hear people or read people say that Newton discovered gravity. I've even read people say that Newton invented gravity, like before him, stuff just floated around. Newton neither discovered nor invented gravity. Everyone knew about gravity. The issue was that some people thought, well, gravity is just that force that operates in this one part of the universe, the part from the orbit of the Earth's moon and in towards the center. Because, of course, people like Aristotle thought the Earth was at the center of the universe. Galileo was the first to suggest that maybe it was one and the same force doing or producing both kinds of motion. Galileo couldn't quite make good on it. Galileo never developed the full theory of gravity that Newton would later go on to. And he didn't develop a full theory of motion, which Newton later would. But a lot of what Newton had to say was following up on Galileo. So you can think of Newton as not so much coming up with a whole lot of brand new ideas. I mean, other than calculus. I mean, Newton created calculus all on his own. But Newton brought together the data and in particular, the mathematical expertise and chops necessary to provide a fully worked out theory, whereas like Galileo had a sketch of a theory. So that's important, right? Providing the first plausible theory of motion and gravity is a big deal. Now, since then, he's been shown to be wrong about motion and gravity and how they work. But he's been shown to be wrong in a very different way than Aristotle was shown to be wrong. Aristotle was shown to be wrong like across the board. There was no part of Aristotle that was right. Aristotle didn't get any aspect of motion or of gravity right, really. I mean, Aristotle didn't even think about motion correctly. Like even his concepts were bad. With Newton, it's different. Newton was proven wrong, but only in that what he has to say doesn't hold true of literally everything. But even the theory which replaced Newton's, which is basically Einstein's, or at least when it comes to gravity, Einstein's theory of general relativity, maintains that Newton's equations get the right answer in a wide range of contexts. It's just when stuff gets really small or gets really big or really fast that Newton starts to fall apart. But for ordinary everyday objects, Newton is still basically right. Or at least his equations still get the right answer. So while he's wrong, he's not wrong in the sort of huge way that Aristotle was. So it's still like a major accomplishment in the history of science. It's not like a dead end. In the way that while Aristotle's theory of physics was probably the best theory of its up to the time he wrote it, and was the theory everybody used in Europe and the Middle East and Northern Africa for like almost 1,500 years after him, more than 1,500 years really, almost 2,000 years. It did end up being a dead end. There's nothing really to take away from Aristotle. So that's all great, right? You invent calculus, you come up with the first really productive, plausible theory of motion and gravity. That's great. Optics, Newton was an early pioneer in optics. All that's great, but it's not why I'm talking about him. Although it explains part of why he had the sort of influence, the intellectual influence he did, especially in the British Isles. In the British Isles, Newton was accepted almost right away. Like his theory was accepted as correct almost right away. It took a lot longer on the continent of Europe, or in continental Europe, for that to happen because, remember, Descartes was a physicist, and Descartes had physical theories. And Descartes' physical theories conflicted with Newton's physical theories. Descartes and his followers were who Newton was reacting against, who Newton was trying to prove wrong and successfully proving wrong. But the debate between them, the debate between the Cartesians and Newton, not between Descartes and Newton, because like Newton was 8 when Descartes died. Descartes died rather young, but even so, he would have been 46 years older than Newton. By the time Newton was writing, Descartes would have been dead anyway. The key dispute between them was over something called action at a distance. Basically, the question was, could one object cause another object to move without coming into contact with each other? Descartes thought no. Descartes thought the only way that causation can function is for one object that has a certain amount of force moving it to make contact with another object and impart its force to that object through the contact. This is something a lot of people accepted. It seemed to be true of what we could observe, right? You don't really see objects just start moving randomly, or not, I mean, I shouldn't say randomly, but like if these two soda cans are separated, you're not going to see like this one go like that and then this one move if they didn't touch. But it wasn't just observation, as you would expect with Descartes, given his rationalist sympathies. It was also that it's the only thing that seemed to make sense, right? Like, how else could one physical object cause another one to do anything if they didn't come into contact, when all a physical object was, according to Descartes, was something taking up a certain region of space? How could it do anything where it isn't? Right? So why is this a debate? Well, it's a debate because Newton's theory of gravity has action at a distance. Newton's theory of gravity says every object exerts gravitational force on every other object. And he has formula describing how that happens, the strength at which would happen between any two objects if you know how far apart they are from each other and how large they are, or I suppose how much mass they have, not how large they are. So if that's true, then right now the Earth and the Sun are exerting gravitational force on each other and are doing so immediately. Because here's what Descartes would have thought about the relationship between the Sun and the Earth. Descartes would have accepted that the Sun was exerting force on the Earth, but he would have said it does so immediately, as in not immediately. So here's what Descartes would have thought was going on. You got the Sun, right? And the Sun, he thought, exerted force on the Earth. I'll draw the Earth over here. Not directly, but indirectly, because what the Sun would do is the Sun would cause the matter in between the Sun and the Earth to sort of swirl. So these were what Descartes called vortices. So there would be, produced by the Sun, a vortex. Now, a vortex of what? Well, a vortex of whatever substance is in space. Descartes didn't think vacuums were possible. He didn't think space could be empty. Again, not through observation, but just because he didn't think it made sense for there to be empty space. He said, like, you can't really think of empty space. You can't really think of nothingness. And what this meant was, he thought outer space, the space in between the Earth and the Moon, or the Earth and the Sun, has to be filled with something. He decided it was some kind of fluid, and that the way the Sun caused the Earth to move was by setting that fluid in motion, because the Sun was directly in contact with that fluid. And it could start the fluid moving, and it would do so strongest close by, right? For obvious reasons, like if you see fluid going down a drain, it's going to be moving at its fastest near the actual drain. It's going to be moving slower around the edges. But still, it would have enough impact on it to cause the fluid around the Earth to swirl, to move, causing the Earth to move along that swirl, right? So the Sun affects the fluid, and the fluid affects the Earth. So it's not immediate. There's something in between them, mediating them, that allows that contact principle, that claim that there's no action at a distance, to still work. A lot of what Newton was up to is showing that this theory doesn't work. That the math of it doesn't work. And you can maybe already figure out what some of the problem is here. Like, if the idea is the Sun causes a swirl and that catches the Earth, well, given that the Moon orbits around the Earth, that has to mean the Earth is causing its own swirl, right? That captures the Moon. But why isn't the swirl from the Earth being completely overridden by the vortex from the Sun? Right? There's issues here. Newton showed, through much more complicated work than that, that Descartes' theory of how gravity worked didn't work. And so he said, look, I just don't think there's a fluid there. There's not. I will point out, Descartes' theory, while wrong, does have some affinities with what Einstein would go on to say. And Einstein shared Descartes' view that there's no action at a distance, or as Einstein called it, spooky action at a distance. It's not that space is a fluid, but space does exist. It's not like nothingness, the way that Newton would have thought. And space can be bent, right? Producing the same basic kind of effect as the vortex. But put that to one side. Newton said, all right, this idea about vortexes or vortices in a fluid that we can't observe just doesn't seem to be right. The math doesn't work. And so I reject this theory of gravity. And in its place, he offered nothing. Now, Newton didn't say there's action at a distance. He didn't say that for sure the Sun was directly acting on the Earth and the Earth was also directly acting on the Sun. What he said was he refused to rule that out if there wasn't any evidence that supported ruling it out. He refused to say that's not how it worked. He did seem to suggest in one of the in a preface to his major work, the Principia, Principles of Natural Philosophy, often just called the Principia, which is Latin for principles. He did say like he shared Descartes' worry that like action at a distance did seem weird, didn't seem like it made sense, but Newton's reaction to that was to just say, well, maybe it doesn't make sense to me, but that's not evidence, right? I don't have any evidence against action at a distance just because it's hard for me to conceive of how it could be true. And there's no evidence that I'm looking at that shows that there's some material in between the sun and the earth that will allow us to rule action at a distance out. Newton used the phrase, which became famous, hypothesis non fingo, which is Latin for something. I believe the first word is Latin for hypothesis. Basically, what he said was, in the absence of evidence, that he was not going to offer some theory of the mechanism by which gravity functioned, that this was illegitimate scientifically, that such a theory, like Descartes' theory, wouldn't have any evidence in its favor, any empirical evidence in its favor. And so there was no reason to believe it, and it shouldn't be included in a scientific theory that sought to base its conclusions on the evidence. And so he just said, look, maybe there's some mechanism doing it. Maybe there's not. I have no evidence to say that there is such a mechanism. So I'm open to the idea that there's action at a distance. This became, for many, many British philosophers, a kind of rallying cry, right? Do not offer hypotheses in the absence of evidence. Don't presume that you know how the universe works unless in the absence of empirical evidence that it works that way. From Newton on, it really started before Newton to a significant extent, but it really picked up steam with Newton. From Newton on, the British philosophical establishment was deeply committed to empiricism, to the rejection of the kind of rationalism that Descartes practiced. Right? So just as Descartes was a rationalist, like Plato was a rationalist, and we saw that Aristotle had a reaction against Plato's rationalism, we're going to see Hume offering an even stronger reaction against rationalism. Hume is going to be a far more consistent and thoroughgoing empiricist than Aristotle was. And he's going to take empiricism so far that a lot of people think his empiricism just ends up as skepticism. Right? So whereas Descartes brought up skepticism so that he could prove it wrong, right? So that he could find a way out of it and he could have this rationalist framework for science, Hume is going to explore the consequences of a kind of pure empiricism of the kind that Newton sort of suggested. And it's going to end up in a significantly skeptical place. And just to remind you, rationalism, I should have color-coded Hume, and in fact I will, I'll do underline. There we go. Rationalism is the view that some substantial knowledge can be known without appeal to experience or observational evidence. Now, I'm going to introduce some terminology here that'll be helpful when we're looking at Hume to make this a little more straightforward. Oh, and by the way, empiricism is basically just the denial of that. It would say no substantial knowledge. Can be known without appeal to experience or observational evidence. This is a little bit of an awkward way to say it because I'm saying knowledge can be known. Really what I should be saying is There's no substantial proposition or claim that can be known. But I want to introduce a little bit of terminology here because it'll be helpful in sort of shortening the sentences when it comes to talking about Hume. All right, so one thing is Latin term a priori. A priori just means known without experience, or really known without the need of experience. Like you don't need experience or observational evidence in order to know something that you know a priori. Right? A posteriori is known with experience, or really stuff that can only be known with experience. Stuff that you can't know unless you get observational evidence for it. Now, some other terms, and here I'll use some different colors. Analytic and synthetic. Analytic means true by definition. Some claims are. The most common example is all bachelors are male. If you know what the definition of bachelor is, you know that the claim all bachelors are male is true. Synthetic claims are just claims that aren't true by definition. Now, I don't mean that they're false by definition. Something that was false by definition would also actually be analytic, right? So analytic should really be true or false by definition. Right? If you know the definition of the terms involved in the claim, you can know whether the claim is true or false. So for example, if I said this bachelor is a woman, you would know that's false. You would know that it's false because of the definition of bachelor. And so it would be an analytic falsity. Synthetic just means whether it's true or false, definitions don't settle it. Right? So if I say bachelors have less money than married men, you might stop on average, let's say. You might have an opinion about that. You might think about it and go, yeah, that makes sense. I mean, married people tend to have houses, and houses are, big ways to generate wealth over time. So that makes sense. But then you might also think, well, bachelors don't have to pay for kids. Well, that's not true. Bachelors can have kids. But point is, you can know fully well what a bachelor is and have no idea whether bachelors on average have more or less money than non-bachelors. So that's a synthetic claim. So another way to put rationalism is, some synthetic truths can be known a priori, or some people will pronounce it a priori. And then empiricism would say only analytic truths can be known a priori. The idea that empiricists have is, yeah, you can prove analytic claims true without experience. Like, let's say you lived in a weird community that had no bachelors in it. Because we don't normally call, like, teenage boys or younger boys bachelors because, like, that's just weird, right? If an 11-year-old introduced themselves to you as a bachelor, you'd be totally creeped out. We normally wait till they're adults to say that they're bachelors. And even then it's a little odd. Like if you just turned 18, it's like, congratulations, son, you're a bachelor. It's like, that's odd. But certainly by the time you're like 22, 23, you're living that bachelor life, right? Unless you've gotten married. But let's say you live in a society where every male has to get married by the time they're 14, right? So they never experience bachelorhood. Nonetheless, so you don't have any experience with bachelors. You've never met one. You've never interacted with one. Nonetheless, you can know that all bachelors are male. If someone teaches you what the word bachelor is, like if someone says, I will tell you now the terrible stories of a land far away where men don't get married until their 20s or their 30s or ever, right? you could then know that all bachelors are male without any experience. Empiricists aren't denying that. Empiricists will be like, yeah, that's fine. You learn what a word means. Now you know analytic truths about the word, but you haven't learned anything interesting about the world, right? I could define anything I wanted. A Zuffenbat, right? Let's say I'm introducing the word Zuffenbat. A Zuffenbat is a dog, right, that refuses to go outside on Thursdays. So now you know that the Zuffenbat was outside on Thursday is false analytically. But I haven't told you anything about the world because, like, for all you know, there are no Zuffenbats. Right? I haven't told you anything interesting about the world. I haven't told you anything substantial about the world. And it's only the claims that are interesting or substantial, claims that, if they're true, they might have been false, that empiricists are interested in. And the idea that a lot of empiricists had was that's basically just synthetic claims. Right? The only way for something to be like contingently true, they thought, was for the words used in stating the claim to like not settle matters. If the words don't settle it, then you got to go check. Right? Analytic truths, it's just mere semantics. You're not learning anything interesting about the world. You're just repeating stuff you know about your own language. So this is the debate. It's been the debate throughout like the entire class. But this is going to be the debate between Descartes and Hume, the same way it was the debate between Plato and Aristotle. Only the difference is Aristotle was a sometimes empiricist or a sort of empiricist. Hume's going to go all the way with it, and he's going to take it to some weird places. All right, so we'll pick up next with the beginning of Hume's most widely read work, and also a work that no one thinks is his best work. Everyone thinks his best work is this very long book. Here, I'll show it to you. I've got it. Called The Treatise on Human Nature. And The Treatise on Human Nature is a big, thick book, and The Inquiry Concerning Human Understanding is a thinner book. And you can't even really tell like how big the difference is here because there's a lot of other stuff in this book. So I'll show you how small it is. Right, so there. Only about 2/3 of this book are the actual inquiry. And there's that. And this has much smaller print than this. Right? So you're lucky that you're only reading the one and not the other. We're reading the book that every Hume scholar thinks is not as intellectually impressive because Hume wrote the first book, The Treatise on Human Nature, when he was quite young. I believe he was in his late 20s, which is just, it's intimidating when you think about that. Someone could write one of the great works in the history of all philosophy in their 20s, which presumably Plato did too. Like the Apology was probably written in his 20s, and the Euthyphro and things like that were written in his 20s. But we're reading the Inquiry because the Inquiry is a much better organized, much better written book. Whereas the treatise, there's like all sorts of long digressions. There's like a half of an argument here, and the second half of the argument is off somewhere else in the book. It's a poorly organized, poorly written book. However, there's a whole lot more stuff in it. So I will from time to time be referring to things that Hume believes, and I'll be referring to stuff that comes out of this, the Treatise on Human Nature, which I'm not asking you to read. So I'll try to make that clear when I do it. All right, that's it for the introduction to Hume.